So now we're working volumes to mass. So the equation that we're going to use for this is N2, so we got nitrogen gas, plus 3 hydrogen gases gives us 2 ammonias that are in a gas. Now, what type of reaction is this? Synthesis. Alright, so we got our synthesis. Alright, now here's the problem. If 5.00 liters of nitrogen reacts completely with hydrogen at a constant temperature of 298 Kelvin and pressure of 3.00 atmospheres, how many grams of ammonia and H3 are produced? Now, this problem is going to be basically 2 problems in one. Now, the first question that we need to ask, are we at standard temperature and pressure, which is 273 Kelvin and 1 atmosphere? Are we there? No, we're not there. So we're not at standard temperature and pressure. So this is going to lead us to the ideal gas law. PV equals nRT. And the reason why we need to do this is because we need this number right here. What's N? The number of moles. R is our constant, our ideal gas constant. All right, so I know my pressure. My pressure is 3 atmospheres. I know my volume. My volume is 5.00 liters. I know my temperature. 298 Kelvin. 298 Kelvin. I also know the constant R. Now, which constant are we going to use with atmospheres? When you check back at the notes, it should be the 0.0821. And honestly, I don't use the units because it has the 4 different units. I just know it's going to cancel into the units we need. And I need N, which is equal to moles. So I'm going to take this, I'm going to say that it's going to be 3.00 atmospheres times my volume, which is 5.00, is equal to N, which we don't know, R, which is 0.0821, and T, which is 298. So first off, volume to mass, if you're given a volume, we actually have to convert it to figure out how many moles we have. So it's a little bit different than what we've done before. Any questions on how we set that up? And we're doing our ideal gas law with that. Now, what we're going to do is we're going to divide by the 0.0821 times the 298. And I'm going to take that over here, 0.0821 and 298 Kelvin. Now these two things divide out. And I'm going to be left with N, which is the number of moles, which is what I want. So I know I'm going to get number of moles here. So we'll just use our calculator. We'll go 3 times 5 is 15. Divide that by 0.0821. Then divide that by 298. And we get 0.613 and change. If we can keep it at 0.613, that 1 in the 10 thousandths isn't going to be a big difference to anything that we're doing. So that's pretty good for what we're doing. So now we know the number of moles of nitrogen. So this is the moles of N2. Please. All right, so now to stoichiometry. We're going to have to refer back to the equation in a second here. I know I have 0.613 moles of N2. So now, the equation is, I need the mole ratio. Alright, so, what's the mole ratio? How many moles of nitrogen to moles of ammonia? Yeah, 1 to 2. So we got 1 to 2 in this case. Now, we have to go moles of NH3 to grams. I know we're going to get 1 mole, and this is going to be our molar mass. Now, we have N and we have 3 H's. So we have to figure out our molar mass from here. Now, remember C and O. And I remember when I was doing this for the first time, I was going in the Navy, so it was Chief of Naval Operations, the highest level. But I also knew that it went 12, 14, 16. They start with 12 and they go up by 2 each. So, what's the grams of nitrogen? 14. So we get 14 grams per mole of nitrogen. Now, what's the molar mass of hydrogen? 1. But we have 3 of them, so it's 1 times 3, so we get 3 grams per mole. Add these guys up, it's 17 grams per mole. So it's 17 grams per 1 mole. And now, once again, we're going to use our math skills here. Multiply by 2, because I had the moles in there already, and then multiply by 17. And we get 20.8 grams of NH3. So to review this, I start with something in liters, and I need to get that I need to figure out the moles. And the only way that you're going to be able to figure out the number of moles is by using the ideal gas law. So use the ideal gas law, figure out the number of moles, and then it just becomes a quick use the mole ratio and the mass to get there. So that's it for that problem. And that's it for what we're doing.